Welcome to the Math Record. Today I'll be covering the ICTM 2021 Division AA Geometry questions 15, 18, and 20. Let's just begin with 15. So in triangle ABC, AB was 5, BC was 11. Point R is the midpoint of AC, and BR equals 4. Determine the length of AC. Okay, so let's just redraw this picture. Okay, so they said this is 5, this is 4, this is 11, and this is a midpoint, so that means this length is x and this length is x. Now we just need to find the length of this entire thing, so x plus x is 2x. So whatever our x is, we just need to multiply by 2. So to solve this, we just use Stewart's theorem. So 5 squared times x is 25x, plus 11 squared times x equals 121x, equals x plus x, which is 2x, times 4 squared, which is 16. So 16 times 2x is 32x, plus 2x times x equals 2x cubed. So that's just Stewart's theorem, which gives us this equation. So that's 25 plus 121 equals 146. We divide out our x's, so that would just be 32 plus 2x squared. So 146 minus 32 equals 114, 2x squared. So that's 57 over x squared. That means x equals square root 57. So 2 square root 57 is our answer for number 15, because we said we need to multiply our x by 2 to get AC. Okay, so let's go to question 18. Circle O contains 3 circles, D, E, H, with each circle tangent to the other 3 as shown. Circle E has radius 7 and circle D has radius 14. Determine the exact radius of circle H. Okay, so a big circle and then a bit smaller circle inside, make it a bit bigger, and then another circle inside, and then another circle just inside those. And we have a line that connects these two. So let's draw the centers of each circle. One's right here, one's right here, one's right here, and one's right here. So we know that this is radius 14 because they told us so in the question. And this is 7. This is 7. So we know this is also 14 because it's also the radius of this circle. So 14 plus 14 plus 7 plus 7 divided by 2, which is just 14 plus 7, which is 21. So the radius of this big circle is 21. So the center is right here, so that means this is 21. But 21 minus 14 is 7 right here. So since this is also 14, because that's the radius of this circle, then this length is 7. And this is 7 for this radius. Okay, so to solve this question, we just need to connect each of these centers on this line to the center of what we want. Now I notice that this radius is 14, because that's just our circle. This radius is 7. And this radius is r, unless this radius is r. Now we need to find this length. So this length, I notice that if we extend it out, this line is exactly this big circle's radius, which is 21 as we said, but we don't want this line, we want this smaller section, but this is length r, so that means 21 minus r equals this length right here. So that is 21 minus r. So that looks pretty ugly, so let's just simplify this to a triangle because we're going to use the same idea of how we solved 15 for this. So line, line, and line. Okay, so this length was 14 plus r, and this was 7 plus r. This was 21 minus r, and this was 7, and the 7 plus 7, so this one's 14. Okay, and let's move this. So using Stewart's theorem again, we have 14 times 14 plus r squared plus 7 times 7 plus r squared equals 7 plus 14, which is 21, times 21 minus r squared plus 21 times 7 times 14. Okay, let's move this a bit over. So first thing I notice is that all of them are divisible by 7, so divide by 7. So that's 2. 14 plus r squared plus 7 plus r squared equals 3. 21 minus r squared plus 21 times 14. So expand this out. So 14 squared is 196. 14 times 2 is 18r, and then r squared. And then we have 7 squared, which is 49, plus 14r plus r squared. That's equal to 3. 21 squared equals 441 minus 42r plus r squared. And we still have 21 times 14. Okay. So let's delete all of this because we don't need this part anymore. And all we have to do is now find what r is. Okay. So 2 times 196, that's 392, plus 49, that's going to be equal to 50, so that's going to 390 for 441, plus 28 times 2 is 56, 56 plus 14 is 70, and 2r squared plus this r squared is 3r squared. 3 times 441 plus 21 times 14. 3 times negative 42 is negative 126r plus 3r squared. So cancel our 3r squares. So all we have is just to solve our linear equation. So 3 times 441 minus 441 is just 2 times 441. And then plus 21 times 14. 126 plus 70 is 196r. So that's just 14 times 14. So r equals 22 times 441 plus 21 times 14 divided by 14 times 14. So cancel out 14. So this is just 21 squared. So 21 is just 3 times 7. So 3 times 7 times 3 times 7. So 7 and 2. So we can't divide another 14. So let's just divide a 7. So divide by 7 is 3 and cancel out the 7. So it's just 3 times 3, which is 9. 9 plus this 3 is 12. 12 divided by this 2 is 6. So our radius, which is our answer, what we're looking for is 6. Okay, now question 20. Quadrilateral ABCD is a rectangle with point E, the midpoint of AB, segment AE equals AD, and AE equals 5. Determine the exact length of the radius of the circle inscribed in triangle DEC. Okay, so let's have a rectangle first. And something right here, here, and now we have a circle. Okay, so they said this was length 5, and since this is a midpoint, this is also 5, and they say AE equals AD, so this is 5, and this is 5. It's a rectangle, so 5 plus 5 equals 10 for this length. Now we just need to find this length and this length, and I know that this is at 90 degrees, and since these lengths are the same, that means these angles has to be the same. So 180 minus 90 is 90, and 90 divided by 2 is 45. So each of these are 45. So this is the same idea. So this is 45 and this is 45. Okay. So what does that tell me is that we could use the 45, 45, 90 triangle rule. So if the side length is 5, we just multiply by square root 2 to get our hypotenuse. So 5 square root 2. And then you could use the formula to find, for in radius, to find this circle for the radius of this circle, because that's what the circle is, an in circle with a radius, which is called an in radius. So that radius is calculated by the area of the triangle divided by 2 times, by a half of the perimeter of this triangle. So the area of this is 5 square root 2 times 5 square root 2 times a half, because that's the area of a triangle, 1/2 times base times height. And then we have 1/2 times the perimeter, which is 5 square root 2 plus 5 square root 2 plus 10. So that is just 10 square root 2 plus 10. And we just need to solve for this equation. So let's move this up because we don't need that anymore. So obviously the 1/2 cancel each other. So 5 times 5 equals 25. Square root 2 times square root 2 is 2. And then we have 10 square root 2 plus 10. So divide 10 out. So that's 5 and a 2. So there's 5 left over. So that's square root 2 plus 1. And we can multiply both this by square root 2 minus 1. So that's just 5 times square root 2 minus 1. Square root 2 times square root 2 equals 2. And then negative 2 and negative square root 2, positive square root 2 cancel each other out. And then 1 and negative 1 makes minus 1. So 2 minus 1 equals 1. So divide by 1 is basically nothing. So our answer is just 5 times, in parentheses, square root 2 minus 1. And that's your answer for number 20. And I already showed this before, but these are all the answers for this geometry contest year. Well, thanks for watching, and in the next video, I'll be covering the Algebra 2.